Students, today we will study electronic devices that is related with semiconducting material. First of all, we have to classify the material on the basis of free electron theory. Materials are classified as means materials are classified as conductor, insulator and semiconductors. On the basis of free electron theory, on the basis of free electron theory, you can say that conductor are those materials which have large number of free electrons. Because these materials have large number of free electrons, hence current can flow through these materials because large number of charge carriers are there, free electrons, such as copper, aluminium, etc. Second is insulator. In insulators, electrons are tightly bound with nucleus, means free electrons are not available. Free electrons are not present. Thus, these are the poor conductors, means these materials cannot allow current to flow. Third is semiconductors have property of conductivity, slight conductivity at room temperature, but at 0 Kelvin these materials behave as an insulator, but at room temperature these materials conduct slightly. The conductivity of these materials lies between conductor and insulator. One very important property of semiconductor is that when temperature is increased, its conductivity increases. It doesn't happen in conductors, because in conductors when temperature is increased, the relaxation time, that is the average time taken between two consecutive collision, is decreased. Hence, when temperature is increased, the resistance of conductors are increased. But these materials have a different property. When temperature is increased, the resistance of these materials is decreased. Thus, these materials have negative temperature coefficient of resistance. Silicon, germanium, these are the elemental semiconducting material. So this is the explanation of the material on the basis of free electron theory, whether free electron is present or not, and if it is present, how easily it can be released by giving the energy. That is in case of semiconductor. If we supply the energy, then definitely electron will be released and the conductivity of the material is increased. Basically, semiconducting materials form covalent bond, means these are the covalent crystal structure. For example, a silicon makes covalent bond with neighboring silicon atom, and in this way complete crystal of silicon is formed. Silicon is making four covalent bond with its neighboring atom. In this way silicon is present in the material. Because of the four covalent bond, the octet is completed for each atom. For each atom, octet is completed because silicon have 284 configuration. Hence, by making four covalent bond with its neighboring silicon atom, its octet is completed. In this way, silicon is present in the material. Now, the semiconducting materials or the materials can also be classified on the basis of energy band diagram. What is energy band diagram? Let us see. Energy band. First of all, understand what is energy band. In every material, there is a group of electrons. Some electrons have higher energy level and some other electrons have lower energy level. The electrons which have such a higher energy level, so that these electrons can conduct electricity, help to conduct the electricity, are placed in a group known as conduction band electrons. This group is called conduction band electron group. Similarly, some of the electrons, means there is a group of electron which cannot help to conduct the electricity because of it is highly in the effect of valence band, in the effect of nucleus, that is in valence band, valence cell. These electrons are known as valence band electrons, and this band is valence band. Thus, you are seeing that there is a gap between conduction band and valence band. This gap is known as forbidden energy gap. Energy gap. Now, on the basis of this energy band diagram, we can explain conductor, insulator, and semiconductor. In case of conductors, what happens? In case of conductors, the conduction band and valence band overlap with each other. What you are observing here, it is the conduction band, and this is the valence band. This is the overlapping area. What you are observing here, overlap, means the conduction band and valence band are overlapping each other. Because of this, electron can easily move from valence band to conduction band and can be used to conduct the electricity. Hence, such type of materials easily conduct the electricity because large number of conduction electrons are present in these materials. Another is insulators. In insulators, what happens? The energy gap between conduction band and valence band is large. Forbidden energy gap is large. Means this is the conduction band and this is the valence band. valence band. And what are you observing here? It is a large energy gap greater than 5 electron volt. But you can be confused from this value that 5 electron volt is only 5 into 1.6 into 10 to the power minus 19 joule, or you can say 8 into 10 to the power minus 19 joule. This energy is very small in amount of energy, but this is the energy required for the one atom. Means for one electron to jump from valence band to conduction band, this much amount of energy required. But millions, billions and trillions electrons will be required to make this material conductive. Hence, when you will calculate for the million, billion and trillion electrons, this value becomes large. Hence, we can say that this value is only for one electron to jump from valence band to conduction band. 5 electron volt energy is required. This energy is very large if considered from one electron. Hence, it is difficult for the electrons to move from valence band to conduction band, and these are the poor conductor of electricity, or no conduction takes place in insulators. Now, in case of semiconductors, see here, semiconductors. What happens in semiconductors? The energy band diagram, when you draw, this energy gap is small. Basically, for different semiconducting material, this energy gap is different. Forbidden energy gap is different. This is conduction band. This is valence band. This forbidden energy gap is 1.1 electron volt for silicon, and it is 0.72 electron volt for germanium. Thus, in general, you can say that it is approximately 1 electron volt. This value is less. Hence, if energy is supplied to the semiconducting material, then electrons can easily jump from valence band to conduction band, and the conductivity of the semiconducting material is increased. And because of this, when conductivity is increased and supplying the temperature or heat, then resistance is decreased. Because of that, it is said that semiconducting material have negative temperature coefficient of resistance. This is the explanation of the material on the basis of free electron theory and according to energy band diagram.